So, continuing from last week, we were doing basic I/O programs, and we introduced, ways that you can format output in both languages using printf style formatting. And then we talked. I don't know. I think we talked about. We talked about variables and variable types. Actually, before we go on to operators, let me go ahead and reiterate a few things here. Best practices on variables practices. Right. So follow a consistent naming convention. Now, there are going to be lots of different conventions that are possible. Some of the major ones are going to be lower camel case, upper camel case, etc. For example, I'm going to suggest that you use lower camel casing for all variables, right? Now, in Java, this is standard, right? In C, it's more modern, right? Question online here. Okay, great. Thanks for joining us online. Anyway, lower camel casing. Why is it called lower camel casing? Well, if you look at it, it's if a variable name is multiple words, it's all pushed together, no spaces, because you can't have spaces at all. But then the first letter of each subsequent word after the first one is uppercase. So it's got these humps, and that's why it's called camel casing. It's called lower camel casing because the first one is lowercase. The first word is lowercase. There's also, of course, a upper camel casing. Alternatives are going to be upper camel casing. That's where all the words, including the first one, are all uppercase for the first letter. And why do you do this? Because it makes it more readable, right? Having those capital letters every single time offsets each word. And this is usually for class names in Java. In fact, that's standard. It is not standard to use upper camel casing for anything other than, say, structures when we eventually get to them in C. Another alternative is to use really old school lower underscore casing. Right? So here, each word is offset not by a capital, but everything is lowercase, and the spaces, since you can't have spaces, they're underscores there. Right? Now, why do I not recommend this? Because to type an underscore, what do you have to do? You have to take your pinky, hold down the shift button, go all the way across to the other side of the keyboard, and type that hyphen to get the underscore. Right? Save your pinky. Right? And also, it's way faster to type lower camel casing, upper camel casing. Ultimately, though, what we're looking for is a consistent naming convention. If you want to use the old school lower camel casing convention, that's fine. Do it everywhere. Right? I don't want to see one variable of one type with one style, and then in the same program later on, there's a variable like a similar variable, but with a completely different convention, completely different styling. Right? Other things that you've also seen, constants in both languages are usually upper underscore casing. Right? Now, there you are, of course, killing your pinky finger by typing all those underscores and the shift button and everything like that. But those aren't the usual forms, right? Those aren't as common as typing out variables. So there's your best practices for naming conventions. Make sure that you're use descriptive variable names. Right? For example, number of students. Does what it says on the box, right? Miles, kilometers, right? Avoid abbreviations, right? Like, so, for example, KMS. KMS could be kilometers, or it could be kilometers per second. I don't know. And the mysterious things like social security numbers and UID numbers, right? SSN, you probably understand that if you're American and you're understanding that that's Social Security, right? That's a Social Security number, unique identifier for U.S. citizens or taxpayers or whatever, right? But not everybody uses Social Security numbers. Certainly not everybody uses NUIDs, Nebraska University Identifiers. If you were to go outside of the state, outside of this entire system, nobody would know what the heck that is. You're not paying by the character, so in some instances, those are okay, right? This is why it's not a rule. It's just avoid guidelines, abbreviations. Definitely do not use variable 1 variable 2, var 3, etc. Right? Don't use those. Those are absolutely terrible variable names. I need another variable. Ask yourself, what is that variable model? What does it stand for? That's the name you should be using. To a lesser extent, don't use X, Y, Z, or A, B, C. Right? That's math. Math is abstract. What does X stand for? What does Y stand for? I don't know. It's a coordinate system, right? Well, it's modeling something, right? That's math. The math folks, I would say, I don't know. It's just a mathematical formula, right? But we're actually coding to solve problems. Problems have concrete ideas. So whatever X and Y are representing in your graph, that's what you call them. A, B, C, no. Avoid those. Or placeholders. You'll see them all over the place. Foo, bar, baz, right? That's geek speak for, they're just common placeholders, right? So definitely do not use those for real variables. All right, well, once we've got variables, we want to do something with them. And that's where operators come in. Operators like the assignment operator, which we've already been using, it's a single equal sign. It takes the thing on the right-hand side and puts it into the variable on the left-hand side. The left-hand side can only ever be a variable. It is not an algebraic equality. This thing on the left-hand side is equal to this thing on the right-hand side. It is an expression. It's an operation. Take that thing on the left-hand side and put it in the, or right-hand side and put it on the left-hand side. You also have arithmetic operators. Those two are obvious. That's addition and subtraction. Less obvious is going to be multiplication. If you look real hard on your QWERTY keyboard, there's not an X. There's not a dot. And you certainly can't say A times B by just saying AB like you would in an algebra course. Instead, you need to approximate it with the star or asterisk. Right? That's multiplication. What about division? You don't have the ability to write A with a slash here and then B in the denominator, right? So what do you use? What's the placeholder for that, or what's the most approximate thing on your QWERTY keyboard for it? That thing right there, which is a forward slash or a backslash? Forward slash, right? So this is addition, subtraction, multiplication, and division, right? And it follows the PEMDAS rules. What is PEMDAS? Do we remember what it stands for? Parentheses, exponents, multiplication, division, addition, subtraction. Left to right. Left to right. So, for example, if I write A times B plus C is not the same as A times B plus C. Why? What have I done there in the second version? I've put parentheses. What does it do with PEMDAS? That's the highest priority. The B plus C will get evaluated first, and then the multiplication is applied. This is actually unnatural for programming languages. This is a really inefficient way for a computer to do its algebra. So, but programming languages are not for computers. They're for us humans to read. So therefore, we write them as a human would and use parentheses, as many parentheses as we want to make it absolutely clear. Even if you don't need parentheses, sometimes it's a good idea to put the parentheses just so that you are signaling your intent. I intend for this thing to happen first. Right? All right, so for example, let's go ahead and example. Let's go ahead and write out the following, and I will write it mathy here. X is equal to, help me out here, B squared? No. Minus 4a, what is it, b plus minus? You know what I'm writing here? Quadratic square root of, help me out, b squared minus 4ac, good, all over 2a, and frac, there we go, thank you, negative b. There we go, now we got it right. Now, am I going to be able to write that in code, just like it was typeset up there? If you're interested in how I did that on the fly, I'm using LaTeX under the hood here. When I post the notes, you can see what it looks like. It's another language. It's a mathematical typesetting language. Right? Okay, so let's come over here and try to do that in, say, C. First of all, I need some variables, right? Is this big enough for everyone? I don't know how big it will be on the live stream, but I'm broadcasting in 4K, so it should be okay. Right? So int a is equal to 10. Int int b is equal to 20, int c is equal to 30. There we go. And let's go ahead and go with int x is equal to all that stuff. Let's think about that for a second here first. Is the result of this quadratic formula likely to be an integer? Probably not. So let's come back over here and change it to something that's more likely, a double. Right, there we go. So negative b plus minus square root. How do I get a square root? SQRT. There is a math library function, and I need to, if I'm going to be using math stuff, what do I need to bring in? The math library. SQRT is short for square root. Over here in Java, I'm going to be translating this here in a moment in Java. It's going to be a little bit different. There is no square root function because it's in the math library just like this was in the math library. Instead, it's going to be math.sqrt. And I'll finish that later, but wait a second. Java is way more modern than C. Why are they still abbreviating it SQRT? Right? We're not paying by the character anymore like we were over here in the 70s and 80s, right? So there was a reason to abbreviate it back then. Square root, right? If you could save on even a few characters, you did it. Why are we doing that still in the 90s here when this was introduced? Because it's familiar. Every single programming language that I've seen uses SQRT, even if it's modern, even if it's like brand new. Why? Because it's recognizable to others, right? And they've never actually typed out square root. All right, so b squared minus 4ac, there we go, all divided by 2a. Lots of problems there, help me fix them. First of all, there's going to be two roots. Can you have plus minus? No, we need to choose one of those, plus. Is there a problem here, negative b? No. You can negate variable values. If there was 10 in there before, now it's negative 10 for the purposes of that expression. If it was negative 10 before, now it's positive 10. 0, negative 0. There is such a thing as negative 0, by the way, but it's still 0, right? All right, so there's square root. Can I do that? Some languages allow me to do an exponent, b squared, using this little caret here. C is not one of them. Neither is Java. That has a different meaning. It will compile and it will work, it'll run, but it'll give you a completely different meaning. That is a bitwise exclusive OR operator. So nope, can't do that. Well, what's one obvious thing that I could do? B times b, right? In fact, in this case, that's what I would suggest that you do. It's just b times b. But if you really want an arbitrary power, x raised to the power y, there's another function for you to do that. Pow, from, again, the math library. Pow, what was it? b squared. There we go. B in this case, comma 2. B raised to the power 2, right? And by the way, since this is so simple, pow, b squared, the compiler is going to optimize that away anyway and replace it with b times b, because that's much easier. Right? It's much easier for it to compute. Can I type it like that? The italicization tells me no, there's something wrong here. What do I need? 4 times a times c. There we go. Okay. What about spacing? Again, spacing doesn't matter. Should you put spaces here? Half a one, or half a dozen one, 6 of another, whatever the expression is, right? Okay, yeah, that's a little bit, but these 2 spaces, be consistent. Right? Make sure that you're being consistent here. If I put a space here, then probably want a space right here. That looks a little bit prettier. Okay. Same problem with 2a, 2 times a. Is that correct? No. Why? PEMDAS. I need to take the entire numerator and put it above the entire denominator. I still need these here. There we go. All right, let's take that over here to Java and translate it. What's the only difference? Math dot and math dot. Here's a secret. The math library in Java is the C library. The math library in Python is the C library. The math library in MATLAB is the C library. I could go on and on and on, right? Why write it 50 different times when you can just use the C library that's on any system, right? So when I actually call square root here, it's calling what's called a native function. When I get to it, strict math, square root, there we go. It's a native function. It's native to that system. It's the C library, right? So all of those nice little mathy things that you have over here in C, you also have some of them over in Java. Java, you have maybe a little bit more. Sine, cosine, tangent, right? POW, square root, arcsine, two argument arctangent, et cetera, right? Okay. So there is, let's actually print this out and see what happens. So printf x is equal to, does anybody have their calculators out? They can calculate this for me really quick and see if it's correct. GCC demo. Oops. So here's another trick. On some systems, it's not going to know anything about that math library. So what you have to do is you have to link in the math library. That's -lm, link in the math library. And when it does that, that's perfectly fine. It's just a quirk, a historical quirk on some systems and some configurations. In your handouts, we draw your attention to it anytime we need to. But basically, remember that there is this process with C. That you go from a source to assembly to machine code. Between there, from the machine code over to an executable file, there's another process that I didn't cover that's called linking. It takes that standard library, it takes that standard input-output library, and it brings all those things together to produce an executable file. I wish it was automatic that it would bring in the math library, but for historical reasons it doesn't. So we need to explicitly say, link in the math library. Right? Okay. Oh, NaN. What do you think NaN stands for? Not a number. What could possibly be wrong? Right? So invalid operations. For example, what if I took the square root of -1? Oh, you know what? Sorry, let me put that in LaTeX. There you go. Square root of -1. What is that? I. But in code, it is not a number. Right? NaN. Right? And that's the problem here. B squared was going to be 400 minus 4ac. That would have given me a negative value, a negative radical, an imaginary root. Right? What are some others? Invalid. What if I went 1 divided by 0? Right? This might be inf. Right? In fact, let's find out. Let's go double y is equal to a divided by 0. Right? Oh, no problem. All right. Operations, don't worry about misspellings. All right, there we go. And let's go ahead and print y. Sorry, it's difficult to follow along on the chat there. And let's recompute this. All right, first of all, it's warning me about it. Division by 0, right? In math, is that defined, by the way? No. But what if you took, I don't know if it'll show up here, but what if you took the limit as n tends towards infinity of 1 over n? Or, sorry, 0. That's defined. What's that limit? Infinity. And so, let's find out what it does. Oops. Okay, in this case, it's a floating point exception, and it kills the entire program. Right? Sometimes you'll get inf as a result. Right? Inf or negative inf. Negative inf. Oops. Negative inf. There we go. So those are possibilities. And you need to check for those, which means that you need conditions, which is what we'll get to probably on Friday. Right? But otherwise, those are the operations. Let's look at another operation, remainder. Right? So you can get the remainder after integer division using the percent sign. And what do I mean by that? Well, let's just go ahead and take a look at some examples here. What if I said a divided by 3, or 10 divided by 3, right? So this is division. If I take 10 divided by 3, what will I get? 3.333333. Think grade school division. where you take 3 into 10 and then you put an R up at the top. What does that R stand for? Remainder. So if you take 10 divided by 3, what's the remainder? 3 goes into 10 3 times, but there's a remainder of 1, right? Results in 1. This is read it as mod or modulo, right? Mod is short for modulo, right? So if I say 10 mod 3 or 10 modulo 3, then the result is 1, the remainder. Right? What if I did, say, 10 mod 2? Results in 0. There is a 0 remainder because 2 goes into 10 evenly. What if I said 10 mod, I'm not going to do 1 because 1, what's the remainder? 10, it goes into 0, I guess, because, yeah. Let's go with 3, 4. Results in, 4 goes into 10 2 times with a remainder of 2, right? Okay. Do you want to see another example? Otherwise, you know, it eventually wraps back around, right? Mod 10 is going to have a remainder of 0. 10 mod 11 is going to have a remainder of 10 because 11 doesn't go into it at all, et cetera, et cetera. Okay? So those are remainders. Here's a trick, right? How can you tell if a number is even or odd? Right? Take the mod 2. Right? So in other words, if I go A mod 2. If the remainder is 0, that tells you that it is even. If it's 1, it tells you it is odd. Right? Okay, great. A little bit of an aside here, since it does matter. What are default values? What do I mean by that? Let me come over here and redefine this. There we go. Now, if I were to print out A at this point in the program, what would it print out? Print F, A is equal to percent D, and the line, A. I will bet you $100 because I'm pretty sure it'll print out 0. Right? Okay. What would happen with the same thing over here in Java? Let's get rid of that. Now, I don't have printf, but I do have system.out.printf. Right? Let's run that. In fact, is it even going to let me do that? It's not even going to let me compile. Why? The local variable A may not have been initialized. So in Java, if you do not assign a value to the variable, it cannot be used. That's a compiler error. There's no default value. In C, there's no default value as well. 99 times out of 100, and I'm crossing my fingers here, it will be 0, but it could be anything. So don't read anything into the default values in C. Yeah?
I just have a question about printf. Can you go back to C?
Sure.
So my understanding is printf a equals and then the percent d goes to essentially the variable you put in after the comma, correct?
Yep, right there.
Does that mean you can't have like 2 variables?
You can have as many as you want. B is equal to percent D, C is equal to percent D. So let me go ahead and restore all of those, A, B, and C. You just have a comma delimited list.
Okay, and is it just in orders? Or?
Yes, it's in order. The first placeholder here will be the first variable. Second placeholder will be the third variable. And in fact, if you forget variables, let me finish this out here so it compiles. Int C is equal to 30. All right, so I've got 3 placeholders, but only 2 variables. So the compiler is smart enough to find that out. Wait a second. I'm expecting an integer here because you gave me 3 placeholders, but only 2 variables. Right. Yep. Same thing on both languages. Yeah.
When you're putting a empty variable into an array, though, wouldn't it have a default value?
Java, yes. C, no.
Okay.
Right. So again, in C, there's no default value. It could have what are called garbage values. So there's an old way of doing this with called dead beef. Dead beef, right? So what is dead beef? Well, hexadecimal. Hexadecimal 0 through 9 and then A through F. What words can you make out of just A through F and then 0 for O maybe, 1 for L, right? What kind of hex speak words can you make? One of those words is going to be dead beef. And that used to be a flag value indicating that this is uninitialized memory. This memory has not been touched yet. Be careful because I don't know what should be in there, so I'm going to put in dead beef, right? So that it's not 0. So that if you get weird values expecting it to be 0, you're going to know right away, no, I got dead beef. Right? That's an old embedded systems trick. Right? Here's another thing that you should be aware of. So I've got A, B, C, D here. Let me go ahead and just make these 1, 2, and 3. All right, there we go. All right, well, let me go ahead and compute A divided by B. Now, A divided by B here is going to be 1 divided by 2, which should be 0.04, or 0.05, excuse me, right? It ain't math class, right? So let me go ahead and put that into a double and try to print it. Printf x is equal to %f and the line x. There we go. Oh, you know what? Let me restore C here so I don't get that warning. Right? No warnings. It's perfectly fine, perfectly happy. What should I get here? I should get 0.5 or 0.5, half. I got 0. Why? So the thing on the left hand, or on the numerator, is an integer. The thing in the denominator is an integer. Therefore, the result has to be an integer. So 0.5, right, that's not an integer. What's the integer part though? 0. What happens to that 0.5? It gets chopped off, thrown away, and that's called truncation. It happens in both languages. Right? So let me go ahead and just cut and paste this. An integer and a floating point number are not the same thing. When you operate on two integers, the result must be an integer. No problems here with plus, minus, and multiplication because an integer plus an integer is an integer. An integer minus an integer is an integer, right? That's a closed set. But when it comes to division, right, it presents a problem, right? When two integers are divided, right, the fractional part, the floating point part, is cut off and thrown away. This is not the same thing as rounding or flooring, if you've heard of that term, right? You're just rounding down to the nearest integer. It's not flooring, it's not rounding. Instead, the solution is, it's called truncation, right? And that's what's happening there. The solution is to use a temporary typecast here. The solution is not to throw away integers and make everything a double. Do not do that, right? Because they are not the same thing, they have different uses. Instead, what I'm going to do is I'm going to go ahead and put a double keyword inside parentheses in front of one of the operands. What this does is it tells the compiler, temporarily, for the purposes of this division, treat A as a floating point number. Now a floating point number divided by an integer results in a floating point number that I can put into a double value over here. This is true of every single typed or statically typed language that I know of. C, C#, C++, Java. I can't think of any others off the top of my head, but that's true of all of them. It's not like Python, it's not like JavaScript, where you magically can change the type of the variable dynamically. If you divide 1 divided by 2 integers, that magically becomes a floating point number. That doesn't happen in these languages. Right? So the solution is this. Right? What happens over here in Java? Oops. There we go. And let me just go ahead and system.out and copy that over there. Right. Same thing, we're going to get 0.5. But if I did not have that typecast there, right, okay, fine. There we go, 0.0. Same thing. Sometimes Java does catch things. For example, if you wanted to do, say, I don't know, x is equal to 3.14. Now, x is an integer. Normally, if truncation were to occur, what would happen to that 0.14? Get chopped off and thrown away. But Java, at least, is trying to save you from yourself here and giving you a compiler error. Type mismatch. You cannot convert implicitly a double to an integer in this case. I'm not going to let you compile until you resolve this. Okay, fine. What I'll do is I'll go ahead and put a double in front of it. Or sorry, not a double, but an int, because I want to force it to become an integer. Then truncation will occur. And you'll see that the result here will be a probably a runtime exception because I'm saying that this is a float, and it should be a double, or an integer, there we go, 3. Right? So you do have to be careful when you are mixing these types. That is a pitfall. Okay? And here, I'll cut and paste this so that you can have that in the notes. There's an example. Just need to remember, I'm getting 0, 0, 0 everywhere, or I'm getting a whole number when I should be getting a fractional number, and the fractional part was thrown away. That's when typecasting comes in. Okay? All right. Any questions so far? Yeah, go ahead.
Can you show it on more than 2 variables? Like, does it still work?
Like what do you mean?
Like if it was a divided by b times c.
Oh, times c, something like that.
Yeah.
This will still work because this ends up being a double, and so double times an integer is still a double. Double minus an integer, that's still going to be a double. I have no idea what this will end up being, but let's find out. Yeah, negative 1.5. It'll retain the fractional part. Basically, you could put this double on both of these, right? But you just need it for at least one. Right? Question?
Like all you're doing is turning the a into a floating point number, and then the
Temporarily,
yeah.
right? You're not actually changing a itself, but in the expression you're changing it. Right? It's still an integer. It's still going to be 1. Right? Yeah.
Is that exclamation point G just
Oh, you mean this? Execute the last command that started with a G. Or you could hit up and scroll through all of the previous commands that you have. Or you could go with like gcc a dot or slash dot a. I don't want to, or gcc demo. There. Command completion, tab over, right? And if there's more than one, you can tab, 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 and it'll scroll through. So, yeah, that's the last command that began with a G. Make sure that you don't, that can get you into some trouble. Like, if you think that the last command that started with a G is one thing, but no, it was actually another thing, and I didn't mean to do that, and now, careful. For example, like remove RF, there we go. That's it won't work because it's going to save me from myself, but what am I doing there? RM is short for remove. The R is recursive, remove everything. F is don't prompt me, I mean yes, right? And then slash is going to be at the root of the file system. This ends up deleting everything. It's not going to work because I don't have root access. But if I did sudo rm rf, there we go. Sudo is the command to do something as a super user. Super user do the following. And no, I'm not going to do that. Right. So be careful. All right. And there's also another hacker trick where you can hide something like that in unprintable text in a web page. So if you say, hey, there's this cool command here that prints out hello world really cool, right? Go ahead and cut and paste this into your terminal. When you cut and paste this into the terminal, the hidden characters that you can't see are also cut and paste and executed by the terminal. So be careful just cutting and pasting from rando websites, right? Exactly. All right. So in our last 15 minutes or so here, what I want to do is I want to introduce you to non-interactive input. And for that, let's go ahead and take that quadratic formula that we had before, and let's go ahead and ask for input. Instead of saying int a is equal to 10, et cetera, let's go ahead and prompt the user for the input, and then I'm going to change it so that it's not interactive. So a is equal to int a, b, c, right? And what I'll do is I'll prompt the user to enter a, b, and c, and then we'll go ahead and execute the quadratic formula to give you those two roots. So how do I prompt for input in C? Printf, please enter a. There we go. How do I read input in C? We have printf. What was the other thing? Scanf. And I need to use a %lf because I'm going to be reading in a double. An integer would be D. A single character would be C. When I print, it would be %f. But when I read with scanf, it's lf just because. Right? A. Right? Does that look right? Let's ask our compiler here. There we go. Nope. It expects an argument of type double star. What is a double star? We're not to pointers yet, but it's of type double. What is that just a reminder of? What do you need to put in front of your variable with scanf just because for now? Magic? Not an, it's actually the opposite of an asterisk. It's going to be the ampersand. There we go. All right, read in B, read in C. By the way, that was just a cardinal sin that I just did. What was I doing? Copy pasting. We also call that copy pasta. Don't copy pasta. It now has another meaning, like people just copying and pasting in message boards and stuff like that. But it started in code. Copy pasta code. Why did it start in code? When you copy pasta code, you end up with spaghetti code. Pasta. Right? What does spaghetti code look like? Well, what does spaghetti look like? Right? Can you distinguish one noodle from any other? No. It's a bunch of unreadable stuff, right? It's delicious, but it is not readable at all, right? Yeah. Question?
So on one of the earlier lines of the I forgot to scan %ln, I just scanned in F, and it's still random fine.
That's probably because it only read in at most like 6 decimals. So you got an inaccurate answer, but it was, as in engineering we said, it was good enough. It was close enough. Exactly. Yeah.
I'm just wondering, I know it says please enter A, but I assume that's not really for the computer. How does it know that the one that you input into that line is going to be A?
Because I read it into the variable A here. I read it into the variable B.
So it's just
I read it into the variable C. Yeah, I mean, I could lie, please enter, I don't know, X, right? Or something, right? But I'm saying please enter A, please enter B, please enter C. You cannot protect yourself against the pebcac user. So what is pebcac? Pebcac. The problem exists between the keyboard and the chair. Right? So if I say please enter A and you say I'll just mash my keyboard here, what happens? Well, that's on you, man. Right? You can't reach out of the screen and make them give you good input. Right? So let's go ahead and compute this now. So double X. In fact, I'll call it root 1 and root 2 because we're going to have 2 roots, right? That's ugly, but that's what it is, right? Is there any other way? Root the first, root the second? I mean, yeah, these are bad variable names in general, but in this particular case, I don't have any other better variable name, right? So there's another saying in computer science that there are only 2 difficult things in computer science. One of them is cache invalidation, and the second one is naming things. So it's really I don't know, good enough, right? Yeah.
Wouldn't you call it like the plus and minus root?
You could, but then it's not necessarily, like, depending on the radical, it could be that the plus root is actually a negative value and the minus root is actually the plus value.
I guess. It's just that you're adding.
Yeah, you could root the first root that I added. Now you're getting a really long variable name. Plus square root of, help me out, b times b minus 4ac all over 2a. And make sure that these are well balanced, good, and good. There we go. And getting myself into trouble by copy pasting pasta, but there we go. All right. And let's print them out. Roots are %f and %f end line. So root 1 and root 2. Great. What am I forgetting? The hyphen LM. That'll link in the math library. All right, now it's interactive. Please enter A. Let's go ahead and do what we did before, 10, 20, and 30. What was the problem with that? I end up with imaginary roots, right? Not a numbers. Yeah, nans. What's another thing that could have happened? You know what? To avoid that, let's just go ahead and make B really, really large and A really, really small. 10, 1, 20, and 1. There we go. That works. Right? Pull out your calculators, verify. Right? Not right now. Right? What's something else though? Well, if you want to make A really small, what's the smallest you could make it? 0, 20, and 1. Before I hit enter, what's going to happen? An error, what kind of error? This thing right here. A is 0. When I divide by 0, I get nan and inf. Right? We'll try one more thing. Again, what if I've got that pebcac user? 1. Okay. It jumped all the way to the end, and like I have no idea what you're talking about there. Oh, that ain't no number I've ever heard of. So, what ends up happening is a bunch of zeros, and then it dies out with the rest of the interactive input here, right? But as long as you are behaving and giving it good input, 1, 5, 1 or something, it'll give you the values that are correct. Right? So, the vast majority of software, however, is not written for human-computer interaction like this, right? That's just the tip of the iceberg, and the rest of the iceberg is sitting here under the sea. All software, the vast majority of software, 90, 95%, 99% of all software is not written for humans. Because why do we write software? For automation. Right? Software is written for other software so that this entire process can be automated. At the end, only then does a human see this. And we don't have that kind of conception, or at least most people don't have that kind of a conception, because what do they think of when they think of software? They think of their nice, pretty little phones here that have big blue buttons and stuff like that, right? But that's not what the vast majority of software is. Right? The vast majority of software is to act non-interactively. There shouldn't even be a human in the mix there. So what I'm going to do is I'm going to change this from interactive input to non-interactive input. All right? What I'm going to do is I'm going to read from the command line. So A is equal to A to F of argv sub 1. B is equal to argv sub 2. And C is equal to argv sub 3. Oops. Come on. B and C. There we go. All right, I'm going to compile this, GCC. Now, if I go ahead and hit A out, it's no longer going to prompt me for any of that stuff. Right? Of course, there's going to be a segmentation fault here. There's something wrong. Okay. That's because I didn't provide these as command line arguments. So let me go ahead and go back to our GCC here. When I invoked the command, the executable command GCC, I was actually giving it arguments. GCC, I want you to compile that file over there. It didn't ask me, oh, okay, I'm about to compile something. What would you like to compile? Oh, demo.c. Okay, thank you. How would you like to compile it? Would you like to link in the math library? Yes. Or no, right? We didn't have this interactive process. I just said, compile that file with this library right there. Those were arguments to the GCC command. Likewise, I can have arguments to my program. 1, 4, 1. Those are the good ones, right? I think. Right? And I will get the answer immediately without it prompting me for it. Yeah?
Why are you starting at 1?
Good question. So, we need to understand how this is actually working under the hood, right? So, interactive input is, of course, through scanf, right? However, most let me cut and paste this since we're low on time. Right? Most programs use command line arguments and are not interactive. Right? So from the command line, you can provide non-interactive input. Right? These are called command line arguments or CLAs. Right? So here's an example. If I go a.out, hello, 10, and 3.5, there are actually 4 arguments there. Right? The first argument is always going to be the executable file name. And that's why when you start at 0, that's what you get, right? First of all, argc is the count, the number of arguments, right? Do you remember I told you ignore those for now? Argc and argv. That's argument count, the number of arguments that you get, in this case 4, right? Because the executable file name, A, B, C, is what I'm expecting, right? Argv is a vector. Argv is a vector, or an array of arguments. Argv sub 0 is always the executable file name. Typically a.out for us, because that's all I've ever shown you. Argv sub 1 is the first user supplied argument, right? argv sub 2, etc. argv sub 2, argv sub 3, etc. Right. Dismiss. Right. These are all strings. Right. They're all sequences of characters. So we need to conversion functions, right, to convert from a string to an integer. You use a to I. Right, there we go. Why do you think you use a to I? A stands for alphanumeric or alphabetical character, right? Alphanumeric character. 2, you're converting, and then I stands for integer. If you want to do a floating point number to convert from a string to a float or a double, you use a to f, just like I did up there. Right. Okay. Cool. Let's go ahead and translate this really quickly into Java. Right. Java also has command line arguments. There is no command line here, but it has that's the same idea. We don't have argv. What do we have? Args, args, args. Here we start at 0 because there is no executable file name. If you want to know what the executable file name is, wait, you wrote it. It's demo. Right? So it starts at 0. That's another difference. You cannot convert using a to I instead, or a to I or a to f. Instead, what do you use? Double dot to double dot parse double. Sorry, there we go. Double dot parse double, double dot parse double, double dot parse double. If you were using an integer, it would be integer dot parse int. Right? So I'll put that, or integer dot parse int. There we go. Get rid of all this stuff. The only other difference here is math dot and math dot. And system.out.printf. And now when I run this, uh-oh, I didn't provide it any command line arguments, did I? Because I didn't type a.out141, whatever it is. Instead, what you need to do in Eclipse to provide command line arguments, you need to go up to this play button. Instead of pushing the play button, push the arrow key down, go down to Run Configurations, and hey, what's that? The second tab is arguments. 1, 4, 1. Apply that, run it. There we go. I get the same exact answer. Right. So, command line arguments, non-interactive input. Now, be careful on your first couple of hacks. We do have you do interactive input, and then we move on to non-interactive input, and then we take away all of that interactive input, and again, we're now under the water with the rest of the iceberg. We write software that only interacts with other software. Right? In fact, when we get to unit testing, you'll see that we're not even going to test it like this. This is called ad hoc testing. I'm just typing things out, and it's not very repeatable. It's very brittle. It's not very, it's very error prone, I should say. Instead, what you can do is you can write software to test your other software. That's called unit testing. And we'll get into that later. Because I don't want to have to deal with this problem. I want to write a program once and solve the problem for the rest of my life and never have to deal with it again. Right? That's the whole point of software. Right. What are some examples of prominent human-computer interaction? Video games. That's the de facto. Right? That's what runs, or that's what drives innovation in computers, right? You're always going to find it in the entertainment sector, video games, right? So I run a VR course every spring, and I always get the questions from people outside the area of, oh, what is VR good for? What is VR good for? Games, period. People have tried to make it into productivity stuff or into simulation stuff like that. No, it's still games.
No
Right?
one's paying $1,500 just to play games on a Quest Pro.
Well, Quest Pro is $1,500? No way, is it?
It's ridiculously. It's meant for productivity.
Oh, that thing. Okay. No, you're gonna get an index. That, if you want my suggestion, if money's no object, then an index is where you should go. Forget about the Vives, certainly forget about the entire metaverse ecosystem. Definitely not. Right. So Vive is, an index is where it's at. Right. Any questions? All right, then we'll pick it up there on Friday. Remember, no class, no live stream on Wednesday.